Hi, math lovers. Welcome to notes number 6. I'm going to do a quick little overview of integers and rational exponents. So remember when we have our exponents that they're a shortcut for us. We don't like to write something over and over and over again. It's our shortcut. So if I had, say, like 3 to the 4th power, that's the same thing as writing 3 times 3 times 3 times 3. We don't want to write that every single time. It'll take us forever. We got other things to do. So that's why we write 3 to the 4th power there, okay? So we're going to go ahead, and if I have exponents, all I'm going to do when I'm multiplying is I'm going to add them together. So let me give an example. If I have 3 to the 4th times 3 to the, I don't know, second, notice that my bases are exactly the same. So I'm going to have 4 3s here, and I have 2 3s there. So all together, I'm going to have 6 3s. So I go ahead and I add my exponents together. So that's called the product rule. And taking a look at some of these products that I have here, you can see that when they have the y's, y to the 4th, here I have y to the 4th times y to the 7th. All I'm going to do is add those two y's to get the exponents together. Now, a little more spicy in question B, notice that I've got a 6, a 9, and a 2. So I can go ahead and multiply all of those constants together and get 108. And I'm just going to straight up notice all the z's. I'm just going to add the exponents, 5 plus 3 plus 2, and that's how I get the 10. 5 plus 3 is 8, plus 2 is 10. Okay. So we have a couple other rules there for exponents. This is called the power rule. So anytime you have a power to a power, you're going to go ahead and multiply. So the example I have here is 4 to the 5th to the 3rd. So really, you're going to have that 3 times. 4 to the 5th times 4 to the 5th times 4 to the 5th. Why not just go ahead and multiply 3 times 5? And that's where, oops, sorry, you can't see that. That's where I'm going to get the 15 from, okay? Moving on a little bit, their second power rule is if I have more than one thing in my parentheses, everything gets raised to that power. So do you notice here? Everything gets raised to the mth power. So in my example, I have 7x to the 3rd. So that means it's 7x times 7x times 7x. I have 3 7s and I have 3 x's. So everything gets raised to the 3rd power. The third power rule is when you have a fraction. And that means everything in the fraction gets raised to that power. So here I have the fraction a over b to the mth. So what I'm going to do is I'm raise everything to that power. So the example here is 3/5 to the 4th. So we have 4 3s and we have 4 5s. Now, to be honest with you, what you would do is you would go ahead and you would simplify these. You know, you would not stop with 7 to the 3rd. You would not stop with 3 to the 4th. You'd go ahead and reduce those numbers. So I have a couple examples of these here. You can see that in each of these, I did power to a power. Here in question A, I did power to a power and multiplied the 2 times 3, and I got the 6. And then I went ahead and I popped it into my calculator. 5 to the 6th power, it gives me 15,625. In question B, I'm going to do the same thing. Everything gets distributed. Oh, this is a good one. This would make a nice quiz question. I'm distributing that 3, power of 3, to both terms in the parentheses. That's a nice one. I would not expect you to ever do that problem without a calculator. Okay. And then looking here, they get a little bit more exciting, a little spicier. Again, just being really careful. Everything gets raised to the 3rd power here. And then over here, everything gets raised to the 5th power. Be really careful with the negative signs, okay? You've got a negative sign raised to the 5th power. Negative times a negative times a negative times a negative times a negative. That's going to give you a negative value. So be careful you bring that negative sign down, okay? Let's see what else we have here. 0 as an exponent. Anything to the 0 power is always going to be 1. We can't do the problem if it's not 1. We have to define it that way. So these are kind of, easy peasy fun ones. 4 to the 0 power, 1. Negative 4 to the 0 power, 1. This one, kind of interesting. Notice and see how the 4 is raised to the 0 power. So it's 4 to the 0 power, which is 1. And then they go ahead and they slap a negative sign in front of it. So it's going to give you -1. And then over here, same kind of thing in D. All right. Have fun with your problem set.